Okay, good morning class. So today we're looking at the exercise 1 on functions and inverses or inverse functions. This is exercise 1 on page 35. Okay, so at this point you guys have concluded the exercise already. Okay, so let's go with it. So we are told that x and y values in the table represents the relationship between x and y. State state whether each relation is a one-to-one, one-to-many, many-to-one, or many-to-many. Use your answer to say whether each function in 1.1. Okay, no problem, thank you. Whether each relation in 1.1 to 1.5 is a function or not. Okay, so if you look here, your domain so this maps 1, 1, 1, 1, 1, 1. So for every 1 x this 1, 1. So this is a 1 to 1. The function or relation? Function. So for every 1x is 1, 1. Okay. Look here. There's a repeat here. Can you see it? There's a repeat on your y. So that's 1 to 2. Negative 1. I'm just going to draw that in the set. So remember that's your x and this is set y. So you got negative 2, negative 1, 0, 1 and 2. The values are 5, 2 and 1. So there's negative 2 with 5, 2 and 5. You see that? 1 with negative 2, and 1 with 2, and 0 and 1. So for every x, there's 1 y. Can you see that? So this would be a many to 1. And is that a function? Yes. So it's a function. Why? So later on you will see it will pass the vertical line test. When's a function a function? If it's many to 1 or 1 to 1. Okay. And we spoke about that when we did the examples for exercise 1, for those of you who weren't here. Okay, for 1.3, here you see now, it just makes more sense if I draw it in sets like this. Okay, so there's a 2, a 3 and a 4. There's a 1, minus 1, minus 4, 4 and 5. So 2 maps with 1. 2 maps with minus 2 as well. Oh, sorry, with minus 1 as well. 3 maps with minus 4 and 4. And 4 maps with 5. So this is a 1 to many. And this is not a function. Or I can say it is a relation. A 1 to many relation. Okay. It's fairly simple. Let's go to 1.4. 1.4. Again, your x and your y. So 4, 8, 12, 16, 20. 1, 2, 3, 4. 1, 2, 3, 4, 5. People, that's straightforward. This is a 1 to 1. And it's a function. For every 1x there's only 1 and only 1 y. Okay? In 1.5 of course, let's check that one out. Again, it's your x and your y. That's 0, 1, 2, 3, 4. 1, 3, 5, 3, 1. 0 with 1. No. I actually tend not to write the repeated numbers, okay? It's easy to see. Okay, so it's 1, 3, 5. Okay? So 1 is with 0 is with 1 and 4 is with 1. Not so. 1 is with 3 and 3 is with 3 and 2 is with 5. So this is a many to 1. Function or not a function? Function. Many to 1 function. Okay. It's fairly simple. Let's go to number 2. Apply the vertical line test to decide whether the graph or the graphs below is a function. So what I do is I take a vertical line. Okay. Okay, so this vertical line. I can't seem to pick it up here. Okay. So in the first case, would this graph pass the vertical line test? Yes. As you can see that this graph, the vertical line is cutting the graph at one point only, anywhere along that graph. If that is the case, we will consider it to be a function. Okay. You guys understand? So this here, number 2.1 is a function. Okay, let's go with the next one. Sorry about this now. Yeah, is this a function? No. No, why? Yeah, it does not pass the vertical line test. This line is going through the graph more than one point. More than one place. Okay? So if that is the case, it's not considered a function. So you say here, not a function. Not a function. Okay, and this would be a many to many. Okay. This one here, 2.3. Is this cubic graph a function? Yes. Why? Because anywhere along that curve, it cuts the graph at one point only. So this one is a function. You got 1.4 or 2.4, sorry. Is that a function? No. Why? Does not pass the vertical line test. That would be a one to many function. For this 1x, there are 2 y's. Okay. Let's carry on with our lives. State the range of each graph. State how the range of each graph should be restricted so it becomes a function. So you all agree that this is not a function. The first one is not a function. Why? Does not pass the vertical line test. But if I take this part of the graph only, what is the equation of that line there? Not 2. X equal to 2. Y is equal to 2. So if I take only this part of the graph, would it be a function? Y percent will pass the vertical line test. So how can we restrict that? We then say y is greater than or equal to 2. Or if I took that into account, would that pass the vertical line test? Only this part here. Yes. So you say that or y is less than or equal to. Let's look at 2.3. What's the equation of this line going through there? Y is equal to? Negative 1. If I take that part only, would it be a function? Yes. So in other words, y has to be more than or equal to negative 1 or, if I take that part only, y has to be less than or equal to negative. Is the circle a function? Is the circle a function? Is it cutting more than once? Yes. So it's the function? No. So how can we restrict that? What's the equation of this line going through here? Y is equal to 2. So if I only take that part into account, will it be a function? Right, so in other words, y must be greater than or equal to 2, or y must be less than or equal to 2. Okay. Number 4. Number 4, we are told that given f of x is equal to minus 3x plus 6, calculate f of 1, 0 and 2. So f of negative 1 is going to be negative 3 times negative 1 is 3 plus 6 is 9. F of 0 is 6 and f of 2 is 0. You all agree with that? Use your answer 4.1 to write down 3 elements of the domain of f and 3 elements of the range. Domain is all possible x values. So your x values was negative 1, 0 and 2. And your range was your corresponding y values, which in this case is 9, 6 and 0. Draw the graph for x is an element of all real numbers. Now number 3. So I got minus 1, 0 and 2. So minus 1 was 9, 0 was 6 and 2 was 0. So I take a ruler and I draw that graph. Okay. Draw the graph of f, alright, we just did that, 4.4. Use your graph to explain why f of x is a function. Why is this a function? Because it passes the vertical line test, that's all you write. Okay, passes the vertical line test. What kind of function is f of x? It's a 1 to 1. For every 1x is 1 y. Okay. Let's go to question 5. Here we are told that g of x is equal to that thing. Calculate g of negative 1. So g of negative 1 gives us a 0. G of 0 gives us 3. G of 1 gives us 0. Use your graph in 5.1 to write down 3 elements. So the domain, what is the domain here? Negative 1, 0 and 1. What's the range? Range is an element of the values 0 and 3. You don't write 0 twice. Okay. Draw the graph. So minus 1 was 0. 0 was 3. And 1. As you can see, it's a quadratic function. Alright. Use your graph to explain why f of x is a function. Why is f of x a function? Because it passes the vertical line test. As you can see, for every 1x, this 1 y value. Okay. What kind of function is this? A many to? Okay. Number 6. So here we are given the relation y is equal to plus minus the root of x plus 4. Copy and complete the table and use it to explain why the relation is not a function. So if I put 0 in here, then I'm going to get 4. Not so. If I'm going to put 1 in here, I'm going to get plus minus 1. The root of 1 plus 4. So that's going to give you 1. So it's plus minus 1 plus 4, which is, if it's plus it's 5. If it's minus it is 3. So it's 5 or 3. Not so. If I put 4 in, I'm going to get y is equal to plus minus the square root of 4 plus 4. So it's plus minus 2 plus 4. So it's going to give you, if it's plus it's 6, or if it's minus it's 2. 6 or 2. Okay. The next one, if I put 9 in, you're going to get 3. It's going to give you 7 or 1. If I put 16 in, it's 4. It's 0 or 8. 25. It's 9 or negative 1. Okay. So is this a function? No. Why? This is a one to many relation. Okay. Will you guys understand? Any confusion? So that brings us to the end of exercise 1 on page 35.